Welcome to my class Physics Untold. Here I am representing one of the question from Pathfinder for Olympiad and JEE Advanced Physics. And this question is from the laws of motion and this is MCQ number 2. So let us start the question. The question is, in the setup shown, a thread is taught between a nail A on the wall and nail B on an inclined plane as shown in the figure. You can change the length of the thread by changing the location of nail B. A bead that can slide on the thread without friction is released from nail A. What should be the length of the thread B so that the bead reaches the nail B in the shortest time? So for solving this question, first of all, let us analyze the question. So there is an inclined plane whose angle of inclination is theta, and there is a wall. On this wall there is a nail which is fixed, and the point of fixing the nail on the wall is A, and from the point A rope is taut whose another end is on the surface of the inclined plane, and let the point where the fixed point on the inclined plane of the rope or string is B. Now we can arbitrarily change the location of the point B on the inclined plane. So if we are changing the location of the inclined plane, point B on the inclined plane, then we can choose any point for fixing the point B on the inclined plane. So let us first assume this is the point where this is the position of the rope, and which is the point B on the inclined plane, and this may be another position of the rope, maybe this alignment, and so on. But for the asked question is what should be the minimum length of the rope for which the bead which is sliding along the rope or the string which comes at the point B on the inclined plane at least or minimum time. So first of all, for solving this question, let us fix an angle alpha. So let this angle is equal to alpha. This angle is represented by alpha. Now as we are knowing that the acceleration due to gravity is acting vertically downward, so this is the direction of the acceleration due to gravity. So if this is the direction of the acceleration due to gravity, now if we divide or resolve the acceleration due to gravity into two mutually perpendicular components, therefore the one of the component of G which is along the rope or string should be equal to G cos theta. So let this component is equal to G cos theta, and its perpendicular component should be equal to G sin theta. Now as the bead is moving or sliding along the rope or the string, therefore the effective component of acceleration due to gravity is equal to G cos alpha, which is the acceleration which is acting on the path of the motion of the bead. Now let this is our angle alpha, which is the angle made with the wall and the rope or the string. So if this angle is equal to alpha and the angle of inclination is equal to theta, therefore this angle is equal to pi divided by 2. This angle equal to pi divided by 2 minus theta. Now let us calculate this angle which is making at the point B. So if you calculate this angle, so for calculating this angle we can calculate the angle B as we are knowing that the total angle made in a triangle is equal to pi, therefore the total angle equal to pi minus the angle formed by the two points, which is at the bottom or bottommost point of the inclined plane, and another point is at the A. So this summation of these two angles is equal to pi divided by 2 is equal to pi divided by 2 plus pi by 2, or pi divided by 2 minus theta, pi divided by 2 minus theta, which is this angle, plus alpha, which is this angle. So angle made at the point A, which is equal to pi divided by 2, this angle is equal to pi divided by 2 minus alpha plus theta. So this is the angle which is made at the point B. Now for solving this question, so let us find the time taken. So time taken can be find out by using the equation of T. Now as we know from the kinematics, T square equal to 2L divided by effective component on the length of the string or length of the path. Now as we know that the length of the path is equal to L. So this is, let this distance or this length equal to L, and the component of the acceleration which is acting on the pathway of the string or on the length of L is equal to G cos alpha. Now again we can find or establish a relation between the L and H, where H is the height between the point O and the point A. Now we can use the sine law. By using the sine law, we can write L divided by its opposite. This is L, length L, divided by its opposite angle. Now as from the diagram we are seeing that the opposite angle of the length L is equal to pi by 2 minus theta. Therefore this ratio should be equal to L divided by sine pi by 2 minus theta, which must be equal to H divided by its opposite angle, which is equal to pi by 2 minus alpha plus theta, and sine of it. So by sine law we are getting L divided by sine theta by pi by 2 minus theta equal to H divided by sine pi by 2 minus alpha plus theta. The another name of this formula is also called Lami's formula. Lami's formula. Now from this relation we can easily find out the value of L. For finding the value of L, or from the relation of T, so this is our equation number 1. This is our equation number 1, and if you substitute the value of L from this equation, so first of all let us find the value of L. So now the value of L is equal to H into sine pi by 2 minus theta, which is equal to cos theta. So L equal to H cos theta divided by sine pi by 2 minus alpha plus theta, which is equal to cos alpha minus theta, or we can write the equation for T square. Now as we are getting that sine pi by 2 minus theta equal to H divided by sine pi by 2 minus alpha plus theta, which from this equation we are getting L equal to H divided by cos theta equal to H cos theta divided by cos alpha minus theta. Now we can substitute the value. Of L from the equation number 2 or from this equation. If we substitute the value of L from this equation into the equation of time, therefore we are getting the square of the time, or T square, must be equal to 2 into L, but value of L is equal to h into cos theta divided by g cos alpha minus theta. Now if we simplify this equation, then we can take the proportionality sign, because as we are observing from this question that angle of inclination for a fixed inclined plane is constant. If therefore theta can be said as constant, if theta is constant, therefore cos theta is must be constant, and h is also a fixed length h. So therefore this h cos theta is a constant term. Therefore if we take the constant, take the equation in proportionality form, then in the proportionality form we can write that t square must be equal to 1 divided by t square must be equal to t square proportional to 1 divided by cos alpha minus theta, because here the 2 is constant, h is also constant, as the theta is constant, therefore its cosine cos theta is also constant, and as the variable angles are alpha, therefore again the variable angle is alpha minus theta, and g is also constant. Therefore for getting the proportionality equation from equality equation, we can eliminate the, or we can skip the value of 2h cos theta divided by g. After skipping this value, we are getting t square is proportional to L divided by cos alpha into cos alpha minus theta. Now we can use a little bit trigonometric identity. If we use the trigonometric identity, then as we know, the from trigonometric identity, cos alpha into cos alpha minus theta, which must be equal to cos 2 alpha minus theta plus cos theta after solving this trigonometric equation. So we are getting the minimum time required, that is when t is minimum. Therefore this equation for t square, which is again proportional to 1 divided by cos 2 alpha 1 divided by cos 2 alpha minus theta plus cos theta. For now, for getting the minimum time t, then for getting for t to be minimum, the value of denominator of this term, that is cos 2 alpha minus theta plus cos theta, should be maximum. This value should be maximum. Now as we are knowing that the theta is fixed, as theta is fixed, therefore we can vary only the value of alpha. So if we are willing to find out the maximum value of this expression cos 2 alpha minus theta plus cos theta, then we have to find out the maximum value for cos 2 alpha minus theta, and we know that the maximum value of cos 2 alpha minus theta, its maximum value is equal to 1, and this maximum value is again equal to cos 0. Therefore we can write the angle 2 alpha minus theta must be equal to equal to 0. If this 2 alpha minus theta is equal to 0, then we can write the relation as alpha, or 2 alpha equal to theta. If this 2 alpha equal to theta, then we can write the alpha, value of alpha is equal to theta divided by 2. So for getting the minimum time or minimum required time, the value of the trigonometric expression must be maximum, and for getting the maximum value of the trigonometric identity, which is equal to cos 2 alpha minus theta plus cos theta, this expression must be maximum. And also in this expression, the as theta is constant, therefore cos theta is also constant. Now only variable quantity is equal to cos 2 alpha minus theta. If this cos 2 alpha minus theta can be varied, therefore the maximum value of cos 2 alpha minus theta is equal to 1, which occurs only at the point 0 or when the angle is 0. Therefore we can write the cos 2 alpha minus theta equal to cos 0, or from this equation we can again write 2 alpha minus theta equal to 0, or 2 alpha equal to theta, or alpha equal to theta divided by 2. So for T minimum, so T minimum occurs when alpha equal to theta divided by 2, and as we are knowing that the minimum time, the minimum length, from this equation, from the sine law or Lami's formula, for minimum time, therefore we can write for minimum time to reach the bead from point A to point B along the string, that should be equal to L sine theta, L sine pi by 2, L sine pi by 2 minus alpha plus theta. Now if we substitute the value of alpha in this equation, then we can write this expression should be equal to L sine pi by 2 minus theta divided by 2 plus theta must be equal to H sine pi by 2 minus theta. Now if we simplify this equation, after a little bit simplification, we can write the value of L must be equal to H sine pi by 2 minus theta, which is equal to cos theta, and divided by sine pi by 2 minus theta divided by 2. Now 1 divided by sine pi divided by 2, 1 divided by sine pi divided by 2 minus theta divided by 2, that is equal to cosec, that value equal to cosec theta divided by 2, or as we are knowing that L equal to H into cos theta, and again it is multiplied with the coefficient of L. Now the coefficient of L is equal to sine pi by 2 minus theta divided by 2, that is cos pi by 2 minus cos theta divided by 2. Now reciprocal of this cos theta divided by 2 equal to sec theta divided by 2. Therefore we can write the minimum time required for the bead to reach from point A to B along the string or along the rope will occur when the length of the rope or the string must be equal to H cos theta into sec theta divided by 2. Now this is our required answer for the given question. Again we can solve the question in different way, or method number 2. In method number 2, we can use the maxima minima theorem. So as it is all the requirement mentioned in our question, that in the setup shown a thread is taught between a nail A and a wall, and in the setup shown a thread is taught between a nail A on a wall and a nail B on the inclined plane as shown in the figure. You can change the length of the thread by changing the location of the nail B. A bead can slide on the thread without friction is released from the nail A. What should be the, now our required question is, or required criteria is, what should be what should be the length of the thread be so that the bead reaches the nail B in shortest time. Now we can again solve this question by using the maxima minima theorem. So let this angle is equal to theta, which is also mentioned in our question. Therefore this much angle is equal to pi divided by 2, this much angle equal to pi divided by 2 minus theta. Again, if this angle is equal to theta, then let us imaginarily draw a line which is parallel to the horizontal surface, then this angle must be equal to theta, and let this angle is equal to beta, this angle equal to beta, or let this distance equal to x or L, anything. So if this angle equal to beta, then this angle must be equal to pi by 2 minus pi by, this angle must be equal to pi by 2 minus beta. This is the angle which is made at the point A. Now if we resolve the acceleration due to gravity into mutually perpendicular components, therefore as we know all know that the acceleration due to gravity is always acting in the downward direction, therefore this is the direction of the acceleration due to gravity, and this is the, now the acceleration due to gravity is acting in the vertically downward direction, and this is a line which is parallel to the inclined plane, or which is parallel to the rope or string. And it is also it is clear from our diagram that this angle is equal to pi by 2 minus beta. So if this equal to z, then the acceleration component along the string or rope must be equal to g cos pi by 2 minus beta, which is equal to g sin beta. Now we can write the time required t is equal to, from we can use the kinematic equation. From the kinematic equation we can find out the time taken, which is equal to under root twice the length of the path, or twice the length of the string or rope, which is equal to 2L divided by the acceleration component, which is equal to g sin beta. From this equation, now we can use for finding the relation between the age and the length of the string. We can use the Lami's theorem or the sine law, or we can write from Lami's formula, Lami's theorem, from Lami's theorem or sine formula or sine rule. We can write the length of the string, which is taken as or assumed as L, divided by its opposite angle. Now from this diagram we are seeing that the opposite angle of L is nothing but equal to pi by 2 minus theta, and from the Lami's theorem or sine rule we can write length divided by its sine of its opposite angle. So this ratio must be equal to L divided by sine pi by 2 minus theta, which must be equal to any other side, ratio of the any other side and sine of its opposite angle. Now let us the another side, which is equal to h. Now the opposite angle of h from the diagram is equal to theta plus beta. Therefore the ratio should be equal to sine of h divided by sine of theta plus beta. Now the form of the Lami's theorem or sine rule is equal to sine L divided by sine pi by 2 minus theta equal to h sine theta plus beta, or we can modify this equation after a little bit simplification. Then we can write L divided by sine pi by 2 minus theta, which is equal to L divided by cos theta equal to h divided by sine theta plus beta, or we can write the length L as equal to h cos theta divided by sine of theta plus beta. Now we can substitute the value of L in this equation. If we substitute the value of L in the equation of the time equation, then we can write the time required must be equal to under root 2h divided 2h cot 1 divided by, now this equation is equal to 2L divided by g sine theta. Now this equation must be equal to 2h cot theta 2h cos theta divided by g sine beta into sine theta plus beta. Now let this expression, which is the denominator of our time function. Now let the denominator of our time function, which is equal to g sine beta into sine theta plus beta. Now as we all of us know from the diagram of this question that as h equal to h is fixed or constant, h is constant, or therefore 2h must be equal to constant, and theta is again constant. If theta equal to constant, therefore we can write its cosine, that is cos theta, must be equal to constant, but only the variable quantity, that is beta. Therefore the quantity or expression, that is g sine beta into sine of theta plus beta, which is variable. Let this variable is equal to y. So for time to be minimum, the variable y must be maximum, or to find the maximum value of y or y to be maximum, we can write the maximum minima theorem. From maxima minima theorem, for any quantity or any expression to be maxima or minima, its first derivative must be 0. We can set its first derivative must be 0. Therefore, as in our calculation or in our expression, it is given that y maximum, y equal to g sine beta into sine theta plus beta. Again, g is a constant, therefore we can exclude g from this equation also. Or y to be maximum, we can write dy. From maxima minima theorem, we can write dy with respect to d beta, because here the angle beta is a variable. Therefore if we derivative or differentiate our expression y with respect to beta, that must be equal to 0. Now if we differentiate this equation or expression of y, therefore after differentiating y, that with respect to beta, that should be equal to dy with respect to d beta, which must be equal to, now differentiation or of the right hand side, differentiation of this expression, which is derivative or differentiation of sine beta into sine theta plus beta, which must be equal to sine beta cos of theta plus beta, because this sine beta is variable. So first we derivative or differentiate the expression sine of theta plus beta, which equal to cos of theta plus beta, and at that time we were taking the sine beta as equal to constant, and after that we can take the term which is already taken as variable, now have to set as the constant term. Now we can write this expression as equal to cos beta into sine theta plus beta, which must be set as 0 for finding the maximum value of y. So if we are willing to find the maximum value, as where we have to set this equation as 0. So if we simplify this equation, which the equation which is equal to sine beta cos theta plus beta plus cos beta into sine of theta plus beta, this expression can be written is fulfilling the criteria of trigonometric identity, which is in the form of sin A cos B plus cos A sin B, which must be equal to sin of A plus B. Now A is beta and B is theta plus beta. Therefore, we can write the whole expression as equal to sin of A plus B, where A is beta and B equal to theta plus beta. Or in a nutshell, we can say this expression should be equal to beta plus beta, which is equal to 2 beta plus theta. Now the 2 beta plus theta to be maxima or minimum. So this, for maximum or minimum, this expression must have to be maxima or maximum. So now the maximum value of, or minimum value of sine 2 beta plus theta or any angle, the maximum value of sine of any angle is equal, minimum value is equal to 0. Therefore, we can write this expression as equal to, or the minimum value is on not only 0, it is multiple of pi, or its value equal to 0 or pi and so on. So if we are taking the one of the value is equal to pi, therefore we can write this expression equal to, or it should be equal to sine, it should be equal to sine pi, or we can write our expression as 2 beta plus theta equal to pi, and from this equation we can write 2 beta equal to pi minus theta, or if we divide the whole expression by 2, therefore we can write beta equal to pi by 2 minus theta by 2. This is our required relation between the variable angle beta and the fixed angle theta. Now we have to substitute the value of beta. Now we have to substitute the value of beta in the expression of the length, required length. So using, as we already write the equation, L equal to h cos theta divided by sin theta plus beta. Now instead of beta, we can write this angle beta equal to pi by 2 minus theta by 2. Therefore, our required length is now becoming L equal to h cos theta divided by sine of value of theta is equal to pi by 2 minus theta divided by 2 plus pi by 2 divided by theta divided by 2. This is, now the value of theta is taken as theta, and the value of beta is equal to pi by 2 minus theta by 2. Therefore, if you subtract the value theta minus theta by 2, theta minus theta by 2, that should be equal to only theta by 2, or our expression is now becoming L equal to h cos theta divided by sine of pi by 2 plus sine of pi by 2 plus theta divided by 2. Now this angle pi by 2 plus theta by 2 is in the second quadrant, and in the second quadrant this sine will be converted into the trigonometric identity cosine, and in the second quadrant is sine is positive, is a positive quantity. Therefore we can write our value, therefore we can write our required value is h equal to, or L equal to h cos theta, L equal to h cos theta into reciprocal this divided by sine of, this should be equal to cos theta divided by 2, or our required value of L is now becoming equal to h cos theta into reciprocal of cos theta divided by 2, which is equal to sec theta divided by 2. So in our first method, this is our required expression or required solution. This is our required expression or the required solution for the given question. now our given answer is equal to, in the second method, is equal to L equal to, which is equal to H cos theta plus cos theta into sec theta divided by 2. It is obtained using the maximum minima theorem. And in our first method, we already find out the value of L, which is equal to H cos theta into sec theta divided by 2. It is using the trigonometric expression. And in the second method also, our result is L equal to H into cos theta into sec theta divided by 2. So two results in two different methods are same and equal, same and they same. So therefore we can also verify the solution of this question or the solution of this problem in two different methods, which now hence the question is solved. Thanks for watching this video. Like, subscribe and share this video for getting more video of this type. Thank you.